biological living tissue, and the only place to get it is from cadavers or animals. The problem is that this is really expensive and it's very hard to attain. So in order to solve this problem, people are starting to 3D print biological tissue. There are commercially available 3D printers out there, biological 3D printers, but they're really expensive as well. So we are teaming up with UVM Medical School, the laboratory of Dan Weiss, to find a more economic way to 3D print biological tissue.
The main objectives of our project were to create a bioprinter out of a prefabricated 3D printer. This printer needs to be capable of printing a biomaterial and curing the layers, and keeping the resolution of that material close to that of native tissue. It also needed to be easy to use, not too software intensive, as well as be compatible with MRI and CAD programming. Our 3D bioprinter. We've taken the MakerBot and removed the extruder, and we've replaced it with this customized dispensing unit. As you can see, the main component is the stepper motor, which was taken from the original extruder, and it drives this screw and pushes out the material.
So we took polyethylene glycol diacrylate, which, as you can see, is a polyethylene with two acrylate groups on the sides, and we mixed it with a photo initiator, commonly used for bioengineering standards. So we have one. We mix those into solution in DI water, and with the addition of some UV light, it produces long chains. Those long chains interact to form a polymer lattice, which is effectively cured.
Testing proceeded with the printer and a cheaper material, alginate. Here we used the Replicator G to generate a G-code used to control the MakerBot. The parameters we changed were filament diameter, nozzle diameter, feed rate, and added a movement of the nozzle between layers to allow for curing. After about a week of these tests, we had determined a good set of parameters that dispensed the right amount of material from the syringe. Once we found these settings, we were able to print samples to be tested on the rheometer to find the material properties.
So our project for the 3D bioprinter was definitely a success. We've been able to totally redesign the nozzle so that it can print different biological materials. And we were able to successfully cure 5 layers to each other seamlessly. So that was really like a benchmark for this. And so the main final goal for the future is to be able to print the third generation bronchial and be able to seed it with cells so that we can have viable lifelike test specimens.